So I wrote down here key idea, like charges repel, unlike charges attract, neutral charges attract both or are attracted to both, and by rubbing. If you know that, fine, but that's basically the summary of last day. Nick, we got a problem. An electron's charge is so small. When you go to a store, do you buy individual eggs or do you buy eggs in a package? In a package. In fact, what's a group of eggs called? A dozen. A dozen. Okay? And the reason is one egg's kind of a small, no one eats one egg, very few. You buy them in groups. Well, so there's a name for an even larger group of eggs. We call it a dozen. Turns out we don't measure charge in electrons. So in our notes, and let me find where I left off with our notes with you guys, Mr. Dewick. A neutral object has an equal number of electrons and protons. That's what neutral means. And if it gains or loses electrons, those of you that were standing on the chair touching the Van de Graaff generator, if you gained or lost electrons, we need a way to tell how many electrons have been moved, but we don't want to count them by electrons because we'd be having answers in the quintillions or heptillions. It'd be huge numbers. An electron is so small that we also, like eggs, count them in groups. We have a unit of charge. The same way as we measure liquid in liters, we have a unit of charge. We measure charge in coulombs. Let me make that bigger. Named after a scientist whose last name was Coulomb. Okay. 1 coulomb contains 6.25 times 10 to the 18th electrons. I wrote out that number. 6.25 times 10 to the 18th. That's a 6 and then 18 more decimals. The first 2 decimals are a 2 and a 5 and then 16 zeros. I can see Trevor wondering, 1,000, million, billion, trillion, quadrillion, 6 quintillion, 250 quadrillion electrons in 1 coulomb. 1 coulomb is a lot of charge. If you absorbed 1 coulomb all at once, probably it would kill you. Certainly it would burn you. A typical lightning bolt contains about 15 coulombs. Oh, and the abbreviation for coulomb is a capital C. One electron has a charge of negative 1.6 times 10 to the negative 19 coulombs. That's 0.00, 18 zeros, and then a 1 and a 6. Oh, and a proton has the same charge as an electron, except a proton is... Yep. Okay. So we measure charge in coulombs. Electrons, too small. What are some applications? Well, I showed you one before this lesson, the Van de Graaff generator. That's a cool application, but that's not an industry useful application. That's just cool fun in the science class application. It turns out another one that all of you are familiar with is Saran wrap. The reason Saran wrap clings, remember the tape experiment that we did? When you pull the Saran wrap off of the roll, that's the same as yanking the piece of tape. You're charging the Saran wrap. It clings because of static charge. Now, the reason it clings to the bowls are neutral. Oh, but wait a minute. We said neutrals will attract both negative and positive charge. They'll attract any charge. That's also why if you're using Saran wrap, it kind of wants to stick to you or move around, especially on a dry day. It can be kind of awkward. Another application, reducing air pollution. Small charged particles of dust are attracted to collectors. You just take a metal plate. You may, in fact, you may have an air purifier in your house. If you take it apart and you look close, some of them use a filter, but some of them, to remove dust, just have a charged metal plate. And the charged pieces of dust will be attracted to it, and it pulls dust out of the air. Oh, this is also why dust sticks to computer monitors. Or TV screens. I don't know if you ever wondered, why does because my TV screen is vertical, why does it pick up so much dust all the time? It's actually a static charge. Some other cool applications. Painting cars. So this started about 20, 25 years ago. What they realized is they could give the paint particles a charge, and then they're sprayed to the metal car, and they stick in the same way that the balloon sticks to the wall. Lots and lots of other cool, clever applications. What are some dangers of static electricity? Those of you that gave each other DAPs on the Van de Graaff generator, you saw the danger. I'm looking for a word that begins with the letter S. SP. Sparks. Because if you have sparks around fuel, that's bad. Okay? So the biggest danger is the generation of sparks around fuel. If you ever work at a gas station, you'll learn, wow, there's a whole bunch of safety features on those gas pumps that I never knew were there, and they're all designed to make sure that static charge can't build up. So airplanes and fuel trucks, they actually have to ground them. They attach a piece of metal, a metal wire, to the truck or the airplane, and then they lead it either to the ground, or they'll have a pipe, even better, going into the ground, so they're guaranteed, because the ground itself, if you just drop it on the dirt, might not be that good a conductor if it's really dry. They ground them before fuel is pumped. Grounding is allowing any excess electrons to flow into the ground, which has an unlimited ability to absorb electrons. The Earth can both give up and absorb essentially an infinite number of electrons because it's so big. Okay? Do you guys remember, this was from before Christmas when we watched the Bill Nye video. In your plug, which is the ground prong? That bottom one. Okay, the two parallel ones are where current is going through. That bottom one is purely designed to allow extra electrons to go into the ground. What that means is if you have a three-pronged plug and the bottom part has broken off, you're at risk using that appliance, because whoever designed that appliance assumed that if there was a short circuit in the appliance, the charge could flow into the ground, not into you, because the ground is more conductive than you are. My mom has her favorite vacuum cleaner. It's one of those egg-shaped ones, and she loved it. I hated using it because what she didn't realize, she only used it inside. But when I was a kid, one of my household chores was to vacuum the car. Where is the car, inside or outside? And so I would bring that vacuum, I would put it on the cement, and I would get nasty shocks from it. My mom never realized there was a short circuit in that thing. It scared me to death. Yeah. Yep.
But it's only with her.
It's only with her?
Yeah.
Then I'm going to guess it might be a particular article of clothing that she wears frequently, or a house coat or something. Remember that chart that showed you the electron affinity? She could be wearing a fabric that has a significantly higher or lower electron affinity than you or your hair, and that could be what's causing it. Yep. So if you look at a power outlet, the roundish outlet at the bottom is the ground. Yeah.
What about some of the plugs? They only have two. They use the two parallel ones.
Those are riskier. Okay? Or those appliances have been designed in such a way that either there is no way for a short circuit to occur, or they may have built something inside the appliance that can absorb excess charge. But most appliances nowadays have the full. Let me pause for a second. Put your pencils down, look up. Homework. I'm going to, I think, oh, my pen stopped working just now. I'm going to cross this off. I gave you this, and the other thing that you can now do, I think, is remember the Bill Nye video handout that we worked on before Christmas? At the end of that handout, and if you don't have a copy of it, I'll find it for you, there was these questions here. You can answer those. They're from page 250 to 254 in your textbook. See if you can fill those in, and I will go over the answers to those questions next class, which is going to be tomorrow. Yeah. Okay. Let me pause the video for 1 second.